variation of parameters. So we have a second order linear differential equation, non-homogeneous. Right hand side has something other than 0, and we would like to solve this. As we know, the solution will be given by a sum of complementary solution plus a particular solution, and we assume YC, complementary solution of this, which is in fact the solution of the corresponding homogeneous. So Y1 and Y2 are two solutions, and a linear combination is the complementary solution of this or solution of this corresponding homogeneous. Now, based on this complementary solution, we set up a particular solution. So take y equals yp, particular solution, is just replace c1 and c2 by two variables. Let's say u1 y1t. In fact, u1 is also a function of t, plus u2 y2t. And as soon as we find the values of u1 and u2, we come back here and we find yp, a particular solution, and yc plus yp will be the solution of this differential equation. Okay, take this as a solution of the original ODE. Then we to find u1 and u2, we plug this into the original equation. That means we need to find y prime and y double prime. So let's find y prime. Then y prime is equal to, here we got a product of two functions, same here, so use the product rule. Using the product rule, u1 prime y1 plus u1 y1 prime, I'm just dropping this, plus another product rule, u2 prime y2 plus u2 y2 prime, and we find y double prime. Once we plug in y prime and y double prime here, we get a condition on u1 and u2. But since we have two variables, we can have two conditions and get unique solution. Okay, but when we plug in y prime, y double prime here, we get only one condition. That means we are free to choose another condition. To make this simpler, let's assume y1 and y2 are knowns, but u1 is to be determined. So let's take these two. Okay, this one plus this one is equal to 0. Okay, so u1 prime y1 plus u2 prime y2 equals 0, and for future reference, let's say star. Then, so in this case, y prime is just now u1 y1 prime plus u2 y2 prime. Okay, now let's find the second derivative. Then y double prime is equal to, here is product rule again, so u1 prime y1 double prime plus u1 prime y1 prime plus product rule here as well, u2 prime y2 prime plus u2 y2 double prime. Okay, so I made a mistake here, but let's correct this. u1 prime y1 prime plus u1 prime y1 prime. This prime, this is u1 y1 double prime here. Okay, and now we plug this into the original ODE. Okay, plug this into the ODE, we get, so we have y double prime, which is here, so u1 prime y1 prime plus u1 y1 double prime plus u2 prime y2 prime plus u2 y2 double prime. That's y prime. And look at here. Okay, so we have this equals gt, so pt y prime. So we multiply y prime by p. So let's write down p. So pt y prime, so this will be then pt u1 y1 prime plus, so I'm multiplying here, okay, pt u2 y2 prime plus the third term is qty. Look at here, the left hand side is at least this qty. So we multiply this y here, y by qt, so we get qt u1 y1 plus qt u2 y2 is equal to, the original equation has gt in the right hand side. Okay, and now we simplify this. Here I'm gonna put these two terms together, y1 double prime and y1 prime here and just y1 here, these three terms, and we can factor u1 u1 out. Similarly, from these three, u2 y2 double prime, and here pt u2 y2 prime, and this. So let's factor u1 out, okay, and factor u2 out. Then we get, so in this case u1 out, then we have now y1 double prime plus pt y1 prime, okay, plus qt here, by the way, u1 is out, y1, okay, plus similarly from other three, so we can factor u2 out, then y2 double prime plus here pt y2 prime plus here qt y2 plus remaining, and we have the remaining terms, u1 prime y1 prime, and here plus u2 prime y2 prime is equal to right hand side gt. And we know that y1 and y2 are solutions of the corresponding homogeneous equation. So our corresponding homogeneous equation is y double prime plus pt y prime plus qt y equals 0. And we know that y1 is a solution. That means when we plug in y1 here in the left hand side, that should be 0. So we have exactly same thing here, y1 double prime plus pt y1 prime plus qt y1. So the whole thing collectively goes to 0. Similarly, y2 is also a solution, so collectively goes to 0. Okay, that's the definition of being solution. Then we have only these two terms left, so that is then u1 prime y1 prime plus u2 prime y2 prime is equal to gt, and these are another conditions on u1 prime and u2 prime. Okay, we would only get one condition. We already assumed here, look at star, equation star, and let's say this is double star. Okay, now basically we solve star and double star for u1 prime, then we can get u1 by integration. So we now solve star and double star for u1 prime and u2 prime. Let me rewrite this star over here so we can compare. So we have u1 prime y1 plus u2 prime y2 equals 0. I'm just rewriting the equation. Now we want to solve this. Okay, then let's try to cancel second terms, then we can isolate u1. For we can multiply first equation by something and multiply second equation by something. Let's see it. Look at here second. We have y2 prime not here, so we're going to multiply this by y2 prime, and we're going to multiply this by y2, and then subtract first from second. Or we can multiply one of them by negative, maybe this by negative, doesn't matter, or subtract. Okay, multiply then subtract. Then we have now u1 prime, y1 prime, y2, and this cancel, minus this one with y2 prime, so u1 prime y1 times y2 prime, these two terms cancel, and we are multiplying by y2, so this is just gt y2 minus 0 is this. Okay, now we can solve this for y1 prime. Okay, factor u1 prime out, then we have y1 prime y2 minus, this is factor out, y1 y2 prime equals gt y2. Then u1 prime is, by the way, let me go up, then u1 prime is equal to gt y2 over this y1 prime y2 minus y1 y2 prime. And this is kind of the Wronskian of two functions. Let me show you here. Wronskian of y1 and y2 is given by this determinant y1 y2, y1 prime y2 prime here. When we evaluate this determinant, this is y1 y2 prime minus y1 prime y2. So this is just the negative of this. So if we flip, then we have to put negative sign. This is same as u1 prime equals, let me multiply top and bottom by negative, then negative gt y2 over, now it flips, then this in fact becomes Wronskian of y1 y2. Okay, this is y1 prime. Now integrate both sides with respect to t, then we get u1, in fact as a function of t, is minus gt y2 over Wronskian of y1 y2 dt. Okay, this is how we find u1. So if we go up and look at here, okay, so we had these two solutions, I mean these two equations, we cancelled second terms and we were able to find u1. Now let's try to cancel first terms, then we should be able to find u2. Okay, let me go back here. Now we need to multiply by different functions, and we are trying to cancel first terms. Okay, so here is y1, sorry, this is, so we cancel this. Now we want to cancel the first term, so y1 prime is y1, so multiply this by y1 and multiply this by y1 prime and subtract again. Then the first terms cancel and you can factor u2 prime out from the second. Okay, so basically doing the same steps, let me write down similarly because it will be the same. Similarly, you're gonna get here u2 prime will be there will be no negative sign this time. Okay, you can check gt y1 over Wronskian of y1 y2, and if we integrate both sides we get u2 obviously as a function of t equals gt, that's the non-homogeneous term, times the first solution y1 over Wronskian of y1 y2 dt. So we have u1 and u2, and if we go back then we find thus ypt is u1 y1 plus u2 y2, where u1 and u2 are found using these formulas, where u1 and U2 are found above. Okay, and the whole solution Y, the solution of the original ODE is complementary solution plus a particular solution, and YC is found earlier. In fact, that's C1Y1 plus C2Y2, and YP is just found, where YC and YP are found above. Okay, final.